So it will be easy for us to be able to move. So the lesson is starting. We are dealing with organic chemistry 1, and we are dealing with alkenes. I want to believe most of the classes you have done the nomenclature, or rather you have done the alkane. So today I'll take you through the alkenes. And remember, the entire organic, I've done it in YouTube. So at your own time, you can be able to follow up the previous lessons that are there. And of course, because this lesson is also being live streamed, of course, you can still be able to review it later. And then I think it's going to be easy for you to be able to capture what you have not got. So let's move together as we try to navigate this topic of organic chemistry. So we start with the anybody with the issue. We start with the areas to be covered. The areas to be covered in my lesson will be the preparation of ethene, that is the preparation of alkane. So with focus on preparation of ethene, because that is what the syllabus. Remember now, this is now the 16th gas as per your syllabus. Remember, you are supposed to learn about 18 gases. And this is now the 17th gas, because the only other gas that is remaining is ethane. You already prepared methane and ethane, right? You prepared that, eh?
Yes.
Yeah. Okay, good. So we are looking at preparation of ethene. We look at the physical properties of alkanes, chemical properties of alkanes, and maybe polymerization of alkanes. So we'll start with I want to believe that, is there any class which has not covered alkanes? Of course, they don't know what alkanes are. Is there any class that has not started by what is ethene? The first member of alkene is ethene. The other one is what? What is the second member of the alkene Mbaluka series?
Methane.
The second member.
Propene.
We have the first member being ethene. I think I can just review that kind of a thing. Let me just try to review that topic a little bit. Let me let's look at the. Are you able to see my screen? I'm sharing now the top notebook 3 because those are the notes. So just that maybe somebody can get that. So we are dealing now with alkenes. Eh? So before you get to that, because I've seen there are some few elements who have issues with that. Because I've seen there are a few elements that are not getting this one right. That for alkenes, their names end in E and E. So when you see any organic compound whose names end with "in," it means it contains a double carbon-carbon bond, as captured in this. So they are unsaturated because they contain a double carbon-carbon bond. I'm just navigating through the introductory part of the topic of alkanes, just to make sure that those students who may not have handled this, or rather who might have forgotten, they understand where we are coming from. So we are talking about now the names of alkanes end with E and E because they contain a double carbon-carbon bond. And of course, they are unsaturated. When you use the word unsaturated, it means now it contains the double carbon-carbon bond or triple carbon-carbon bond. Each carbon atom is not fully bonded with the maximum number of hydrogen atoms, of course, because they are unsaturated. The general formula is CnH2n, where n is equal to 2, 3, 4, 5. The first member of the Mbaluka series is ethene and not methane. For that student, we will talk about methane. Remember, there must be, just like in a family. You cannot talk about a family without a man and a woman, because we always say that a man and a woman will have to come and collide with sufficient enough activation energy to bring about a chemical reaction. And that host product is you. For you to come to this world, your father and mother must have collided with sufficient enough activation energy to bring about a chemical reaction. So they had that activation energy. So whatever we are talking about here is we're having a double carbon-carbon bond. That double carbon bond cannot exist if the carbon is one. So they must be at least two carbon to bring about any alkene. Are you getting the point?
Yes.
Yeah, so there must be two so that they can exist the double carbon-carbon bond. So it's not like alkanes. Then we have, they have a double carbon-carbon bond, and that is the double carbon-carbon bond in the functional group. The functional group is the most active site. So like, for example, if we are holding each other, assume like now, I'm holding somebody. We have somebody who is not normal. Can you mute yourself? You need to be very, very, very normal to make sure that you don't disturb the entire congregation. Now we are talking about the double carbon-carbon bond is the functional group. And what is the functional group of a compound, or rather of our homologous series? What do you mean by a functional group? Student, anybody with an idea? What's the functional group? The functional group is the most active site. It's the one that causes the compound to have a lot of reaction. So it is the active site of the compound. So the functional group is what causes the alkane to be highly reactive. As you saw with alkanes, do alkanes have a functional group? Do they have a functional group, the alkanes? I'm not talking to myself. Do alkanes have a functional group?
No. Yes.
We have anaitwa mtu anajiita Gino Gola. Can you raise your hand? Gino Gola, you're in which class? I'm not getting you. In which class? Yeah? So I'm making a course just because to help me in maintaining whatever. Anybody else? Koba, Blair?
Alkanes do not have a functional group.
Yeah, they don't have a functional group, and that's why they are unreactive. In fact, they only undergo two chemical property, that is combustion. And we have combustion and we have the substitution reaction. And they only react in presence of UV light. So that's why there are very few reactions with alkanes, because they don't have a functional group. Let's look at something else. Okay. 3. Okay. Now, let's look at the unsaturated hydrocarbons are compounds with a double or triple carbon-carbon bond. So you can be told to define what is unsaturated hydrocarbons. And you're going to say these are compounds with a double or triple carbon-carbon bond. So we have the members of the alkene series. We have the first member, that is the one with one carbon atoms, does not exist. And therefore, we don't have the formula of it. So the first member of alkane series is ethene, whose general formula by applying this one will be CN, because it has 2 carbon atoms, that is N is 2. So it will be 2 times 2, which is now 4. And the formula of it is this, as shown there. This is CH. There is a double bond there. After putting the double bond, this carbon atom already has 2. So they are remaining with 4 bonds. Remember, each carbon atom has 4 covalent bonds. So hapa kuna 1, 2, 3, 4. The same with the other one. The third member is propene. You just draw 3 carbon atoms, then you put a double bond somewhere. Then you from there, you can now make sure that each carbon atom has 4 bonds. So this carbon already has 1, 2. The other one is 1, 2. So we have 4. So this one now, the central carbon atom has 1, 2, and we have another carbon atom there, another bond there. We have 1 covalent bond, 2, 3. So there is only 1 covalent bond required to make it 4. So that is why now this one is only attached to only 1 hydrogen atom. This one, the first one, has only 1 covalent bond between the carbon and the adjacent carbon atom. So 3 bonds are remaining. So that's why we're going to form another 1 covalent bond with hydrogen, the third covalent bond with hydrogen, and the 4th covalent bond with hydrogen. So they are total 4. So in short, when you're drawing the formula of these compounds, make sure that you are able to just draw. If it is a butene, just draw 4 carbon atoms, then put a double bond anywhere. Then from there, you'll be able to count from one side to the other. Just make sure that each carbon atom has 4 covalent bonds. So look at this. Of course, you'll be able to understand later why we don't say butane. There is no compound called butene, because you have to specify the location of the double bond. So in that kind of a scenario, when you draw a structure like the one that I've shown on the screen, you count 1, 2, 3, 4. From that, you find the double bond is located between the first and the second. Unlike the case of alkanes, when you are deriving the names of alkanes, you start counting from the side nearest to the location of the double bond. When you are identifying the name of alkenes, you start counting from the side nearest to the location of the double bond. And the double bond is designated using the first carbon atom where that double bond is located. Now, let me just take you back, Kidogo, to concept of nomenclature, the naming of alkenes. Here you select the longest continuous carbon chain containing the double bond. That gives you the parent name. You start counting from the side nearest to the location of the double bond. The location of the double bond is designated using the first carbon atom where it occurs. Listen, when we are dealing with alkanes, we said you start counting from the side nearest to the location of the branch. The reason why for alkanes we start counting from the side nearest to the location of the branch is because alkanes have no functional group. But for alkenes, when you are told to name, you start counting from the side nearest to the location of the double bond. Then you indicate that double bond using the first carbon atom where that double bond is located. Look at this. We have this one. We have 1, 2, 3, 4. So here we have now the compound, the alkene. We start counting from the side nearer to the double bond. So the double bond from here, it is more closer to the right hand side. So you start counting 1, 2, 3, 4. So from this end, you can be able to see that the double bond occurs between the first and the second carbon atom. So you are supposed to pick the first carbon atom where it occurs. So if the double bond occurs between the first and the second, it first occurs at the first. You get the lower number there. So you tell us now, this is both, meaning the longest continuous carbon chain has one carbon atom. Then one in. When you say in, it means there is a double bond. Where is it located? Ukiandika one, it means it occurs between the first and the second. Hence, the name is both one in. And then you always remember, between a word, between letters and numerals, letters and numbers, this is a letter, these are words, these are letters. Then you separate numbers and letters using an hyphen. That's why we are putting one, and between in and both, we are putting an hyphen, because those are the rules of UPAC, that when naming and you're putting a number between a name, the letters and numerals, rather the letters and the numbers are separated using an hyphen. Remember, the same thing, we can still have butene, but now instead of putting the double bond in between the first and the second, we put it hapo katikati. In that kind of a scenario, we can count from any side, because even if you start counting from the left or from the right, we are going to have the double bond occurring between the second and the third. So in that kind of a scenario, the name becomes both two in, meaning that these both 4 carbon atoms in means there's a double bond. Where is it located? Between the second and the third. The same for pentene. So we have 1, 2, 3, 4, 5. The double bond occurs between the first and the second. So the name is pent. 1 in. Pent because it is 5 carbon atoms. 1 because it has a double bond occurring between the first and the second. And in, it indicates it has a double bond. Then we can also have pent 2 in. And I think that is very clear about naming of alkenes. That okay?
Mm-hmm.
Yes.
Go sawa?
Yes.
Yeah.
Very magnetic, very, very magnetic. That's good. So that I was just revising that. Then remember that we can also have the branch, the naming of the other branch occurs, or rather, the naming of the other branch is just like done like in alkenes. Kama kuna methyl kwa second carbon atom, utaongeza hapa 2 methyl, put 1 in. Just like that, just like the other nomenclature. The other thing that I don't know whether you've been told, now I can now take you back now to the topic for today. I can now take you to the real chemistry of today that I prepared. But before I continue, that I was saying that we can also have a concept whereby we have more than, we can also have a scenario whereby we have more than 2 double bonds. Like, for example, we can have carbon, we can have carbon, we can have carbon, we can have carbon. Then we have a double bond and another double bond, and we have another double bond and another double bond there. Then we can now have hydrogen. This one already has 2, so we only require another 1 hydrogen. So this one is 1. So how many hydrogens are required to be added to this carbon?
1.
Very magnetic. How many are required here?
1 also.
1 as well.
1.
I can see you're very magnetic students. You are organic intellectuals. You are already organified. So that is very So now we want to name that compound. It is important. You know, some of these things are not in the syllabus, but you need this wisdom, because once in a while, when you'll be dealing with formation of natural rubber, you'll need this wisdom. Because remember, this is the UPA Command Center. This is where chemistry was conceived. This is whereby the father and the mother of chemistry were able to become intimate and give birth to chemistry. Now, so you must be given the most distilled and refined content that can make you to be able to face the world, that can make you paragonic. Now, let's count. We start counting. We can start counting from any side because both of them, we have 1, 2, we have 3, and we have 4. So in that kind of a scenario, we can have, this is the longest continuous chain as how many carbon atoms?
4.
4. So that the name becomes both. But it has a double bond. Where is the double bond occurring? Between the first and the second. And between also the what? So the name becomes what? So here you use the word diene. You tell us this must be a di. Di means 2. So when you say this is a diene, there are 2 double bonds. So you say, you remember, students, when you use the word, when you use the suffix in, it means there is a double bond. Are we together?
Yes.
Yes.
Inamaanisha ni mbili. Ziko wapi? Haya. We are supposed to tell us where are they. Moja iko between the first and the second. So you say 1. Then remember you have to, then the other one, which occurs between the third and fourth. So we pick 3 or we pick 4?
3.
And remember, a number, letters and numbers separated by hyphen. Number and number separated by a comma. Then continuous carbon chain has 4 carbon atom. So the name is diene. Perfect. Can I repeat?
Yes.
I repeat, let me.
Pardon.
Okay, can I just let me pardon for for people who have not understood. If you have more than 1 double bond, these are you name it. You start counting from the side nearest to the location of the double bond. But on this end, we can count from any. Because remember, we can also have counted 1, 2, 3, and 4. So in that kind of a scenario, you see, whether you start counting from the right or from the left, we are still having the double bond between the first and the second, and the third and the fourth. So you come and identify where is the location of the double bond between the first and the second, and between the third and the fourth. When there are 2 double bonds, you name them by telling us how many are they. In stands for a double bond. If there are more than 1, you are going to use the word diene, because meaning diene, di 2, hene double bond. So there are 2 double bonds. Then you must tell us where are those, that the word diene must be preceded by the numbers designating the location of that double bond. Where are those 2 double bonds that you have told us? Unakuja unasema ya kwanza iko between the first and the second. So you pick the first letter, which is 1. So the first double bond occurs between the first and second, unaeka 1. Then the other one occurs between third and fourth, unaeka 3. Between number, to separate numbers, you use comma. Usiandike 1, 3, that becomes 13. That will now be very satanic, because when you write 1, 3, that begins 13, and it means that there is a double bond occurring on the 13 carbon atom, which does not make sense. So 1, 3, when you say diene, to me there are 2 double bonds. 1 occurs between the first and the second. The other one occurs between the third and the fourth. Then we have both telling us the longest continuous chain has 4 carbon atoms. Sawa.
Yes, sir.
Umeelewa sasa?
Yes.
Now let me now continue. Allow me to continue. Now, today we are going to deal with of course, I had to start with that because there are some students who had not understood that concept, but I think now you have ingested, digested, and assimilated the wisdom on nomenclature of alkanes. So I want us to navigate through the deep waters of the alkanes homologous series, and we are looking at the preparation of alkanes with specifically ethene. Hiyo ndio inaleta izaleto kwa mtihani. We have physical properties of alkenes. We have the chemical properties of alkenes. The heart of organic chemistry 1 is on the alkenes. So you have to be very careful, especially with the chemical properties. Most of it will, most of the questions on organic will try to circumnavigate, will oscillate, will always be relying, or rather will always be now originating from alkenes at the central point. So it is important for you to be able to understand. Then we'll be looking at something like polymerization. So by the end of the lesson, you should be able to prepare. Of course, I've prepared several lessons. It depends on the time factor. So by the end of the lesson, you should be able to describe the preparation of alkenes. I think this thing is kidogo tu. I deal with the transitions. So by the end of the lesson, you should be able to discuss the preparation of alkenes, that is ethene, explain the trade in physical properties of alkenes. So I just wanted to, it is in the setting of the slide that issued, but I think I've now disabled the transitions, which was given for a few seconds. Now, I still you're able to see the screen, isn't it?
Yes.
Yes.
Good. So now, with preparation of ethene. In a school, alkenes may be prepared from dehydration of alkanols using 1 concentrated sulfuric acid or aluminum oxide. So there are 2 dehydrating agents. We convert alkenes, we convert alkanols to alkenes by dehydrating. What is dehydration, by the way? Removal of?
That is chemically combined.
Chemically combined water.
Yeah, just listen, that is the wisdom. Dehydration is the removal of chemically combined water. That now brings the difference between dehydration and drying. When you are dehydrating, we are removing a chemically combined water from a substance. Drying is simply removal of water, or removal of moisture from a substance. When you wash your clothes and you put them in a hanging line, are you dehydrating them or drying them?
Drying.
The difference. Moja uende umwagilie sulfuric acid hiyo sweta yako uone what will happen. Itakuwa makaa. We'll even remove the water. You think that cloth you are wearing does not contain water? It has. So of course, that is something that can be able to be done. So if you are removing water that is already chemically combined, like if you pour concentrated sulfuric acid on sugar, it will remove the elements of water, which is hydrogen and oxygen. And therefore now In that kind of a scenario, now the sugar will turn from white to yellow, brown, and finally black because it's converted to carbon. So that's very much important. So
Excuse me.
yes.
Is the chemically combined water the same as the water of crystallization?
Yeah, water of crystallization is part of the compound. So when you remove, that is also when you're removing water of crystallization, you're also dehydrating. But not all substances have water of crystallization. Something like sugar does not have water of crystallization. Something like ethanol. It doesn't mean when you're removing, we have compound with the element of water, but we are not removing the water of crystallization per se, because that water of crystallization is normally found in crystals. Are we together?
Yes.
Yeah, you see, liquid is not a crystal. So you cannot say ethanol, which is a liquid, as a water of crystallization. Are you getting the point? But you are saying it's also the same. When you're now removing water from copper sulfate, that is now that is water of crystallization. So it is okay that to be able to understand that kind of a thing. So when you're removing when you're dehydrating and you want to get an alkane, you dehydrate alkanol using either concentrated sulfuric acid or an aluminium oxide crystal or aluminium oxide. So remember, whatever you're answering question, always specify if you're using an acid, whether it is concentrated or dilute. So we have alkanol, we can use sulfuric acid, we get alkene plus water. Alkanol plus this one, you get the corresponding alkene plus water. That's what I mean by that. Now you look at that. Here we have ethanol. So looking at this ethanol, ukiangalia ethanol, unajua maji inatakanga nini? Maji inataka plus what? What do we need now? Tuko na OH, tunataka kupata maji. Tunataka nini? Tunataka tu hydrogen, isn't it?
Yes.
So we are just going to get this OH na tutoe hydrogen moja hapa. So utabaki na hydrogen ngapi? Sasa hizi ni 5. Ukitoa moja hapo itabaki ngapi? 4. Unaelewa? So this will be drawn C2 H what? H4. We can still summarize the formula of ethanol as C2 H5 or H. So you can simply get this OH. Now draw hydrogen moja hapa. So you remain with C2H4. So if you're having this one is ethanol, if this is ethanol, I think it's important for the student to understand. If this one is ethanol, if this one is ethanol, you get ethene. You get ethene. So you get from ethanol, you get ethene. So if you want to get propane, we are going to dehydrate what?
Propanol.
Perfect. The formula of propanol is 3H7OH. So when now you dehydrate this, the product here will be what? See what? C3H what?
6.
H, then plus water. So we have ethanol. When you dehydrate ethanol, you get ethene plus water. We get ethene plus water. When you get propanol, you get propene plus. It's just as simple as that. And this thing, it means you can even I can tell you, you can dehydrate decanol. Ama donde decanol. Let me give you a very complicated thing. Maybe there was something that you have never met and see whether you can get it. Have you taken a screenshot for this?
Yes.
Of course, this one is anyways in here. So, tuseme tuko na kitu kama hii. I want to show you how to understand chemistry. C11, this will be H 23 or H. The name of this is something that you have not been told, but I'll show you that you can still see. I want to show you how you use the knowledge. This one is called unidecanol. Semulefundwa dec means 10. So when you say unidecanol, uni means 1, then dec 10. So it means 11. So unidecanol, you are dehydrating. What will be the formula here? The formula of the product, I want to show you. It will be what?
C11.
11 H24
H22.
H20 what?
22.
And the name of that?
22. Which will be
You
The
need
name? Uni?
Deki.
Unidecene.
Oh, the unidekin. Anyway, no, hakuna mtu atakuletea hii kitu. But I'm just showing you that very easy to understand how to get any other alkenes. Because if you're having octanol, you're going to get what? Huh? Water. So like that. We okay now? Tuko sawa?
yeah.
So
Yes.
it to be the examiner will ask you what is the reagent. The reagent is concentrated sulfuric acid. Or if you are using concentrated sulfuric acid, is any temperature between 160 and 180. So at the same temperature of I am back. So I hope you are able to see me. Are you able to see the screen? You don't have to see me anyway.
Yeah.
Yes.
Yes. Yes. You see it.
There was a power outage on my end, but I still have other superior powers to generate power. So there is no problem with that. So I'm okay. We are okay. We are perfect. we are good to go. So the scenario is that we are using concentrated sulfuric acid, then we have a temperature of 180. So you can use a temperature of 160, temperature of 170, temperature of 180. You get the corresponding alkene plus water. Na nimekuambia how to go about it. Kama ni ethanol, unachukua tu hii, unaangalia kama hii ni OH, you just need to remove, you just need to remove another hydrogen, then you're going to get the corresponding alkene. That one we have been able to get even using a very complicated compound like unidecane. And I think we are sorted for that. Sawa?
Yes.
So now the other one is now okay, we go to the next. So we have so you can look at now preparation of alkenes, as you can be able to see the diagram is there. We're having the ethanol, then we're having now the ethene plus water. You can be able to see from that end. Then the diagram is there. We are passing through potassium hydroxide. It can also be sodium hydroxide here. An examiner will ask you, why do we need to, what the role of this? What the role of sodium hydroxide and what? And or potassium hydroxide?
To remove CO2.
Yeah, at a very high temperature, we are going to have ethanol may become forming carbon dioxide, and also sulfuric acid may lead to formation of it may lead to formation of what we call sulfur dioxide. So impurity like sulfur dioxide that can come due to decomposition of ethanol and sulfuric acid can now pollute the compound, that's the gas. So we pass it through potassium hydroxide and sodium hydroxide, which will now remove any impurities in the name of sulfur oxide and and carbon dioxide. Sawa?
Yes.
Yes.
Yeah, so the broken porcelain just prevents the bumping and ends make sure that the flux does not break. I'll be able to give you the answer for that still to be able to answer that. So somebody can ask about the broken porcelain and also the sodium hydroxide. So now,
Excuse
I'm saying
me,
the gas. Yeah.
While we heat alkanols, we say that you're going to get an alkene plus water.
Yeah.
And there's a chemical known as methanol that exists, but there's no methane. So if you heat methanol, if you dehydrate methanol, what would happen?
Of course, you cannot dehydrate methanol because they are not going to get nothing from there. Because that's a reaction that will not be able to take place. Because what are you dehydrating? When you dehydrate methanol, you're going to get water and carbon alone. If now if you methanol, the formula of methanol is this. CH3OH. So because it has only one carbon atom, and you cannot get an alkene with one carbon atom. So when you remove the elements of water is hydrogen and what? The elements of water is hydrogen and oxygen. So if you're going to dehydrate methanol, you'll get water and carbon. Sawa?
Yes.
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 Okay.
Yes.
So now we go to the answers for that. I think you're taking a screen, but of course, the good thing, these things are always recorded. The gas produced contains traces of carbon dioxide and sulfur dioxide gas as impurities, and it is passed through concentrated sodium or potassium hydroxide to remove the impurities. So I think that is now very clear for you. That one I've already said. So we go next. Can you move on?
Yes.
Okay. About 180 degrees Celsius, concentrated sulfuric acid dehydrates ethanol to ethane. A broken porcelain or sand is used to prevent bumping, which may result in cracking of the flask. So remember, those are questions that you can be asked what the role of post to cracking, very clear. Sawa? Can I proceed or I'm alone? Kuna watu wako kwa nini ukweli?
Sawa.
Yes.
Okay. Perfect.
Proceed.
Proceed. Remember now we can also dehydrate using aluminum oxide. It dehydrates or removes ethanol to form ethane. But now this one requires a temperature of 300 degrees Celsius. So dehydrating using aluminum oxide, it takes place at a temperature of 300 degrees Celsius. You see now, because most books and most students are used to form ethene, you're using ethanol plus conc sulfuric acid. Now here, there's somebody tells you, we have ethanol, then we have solid A to get ethene. You'll find somebody still saying, this is dehydration, yes. But when they are told, identify solid B, wanasema concentrated sulfuric acid. So you find most books and students put more weight in the use of concentrated sulfuric acid. Even most examiners, they always ask questions related to use of concentrated sulfuric acid. But remember, the aluminum oxide once used, the temperature there is not 180, it is 300 degrees Celsius. Have you got that one right?
Yes.
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 Dehydrating using sulfuric acid, we use a temperature of either 160, 170, 180. But dehydration using aluminum oxide, the temperature is 300 degrees Celsius. And aluminum oxide is a solid. I think I'm clear about that.
Yeah.
Yes.
Okay, good. So aluminum oxide acts as both as the dehydrating agent as well as a catalyst, and the temperature is 300 degrees Celsius. Very key for you to be able to understand. Very smart notes, very clear, very distilled, and straight to the point. Can I proceed?
Yes.
Yes.
So that now shows the water preparation of ethene using aluminum oxide, and the temperature is shown there. It's very easy. So we're having the glass will soaked in ethanol. So you first of all heat it to generate ethanol. The ethanol is easily volatile, so it passes through the aluminum oxide, which is heated. Heat is also, this one is also heated. The temperature is maintained very high. So to get now ethane, that's now the setup that is used. You can be told aluminum oxide was, these are the things that examiner will tell you. Draw a setup for preparation of ethene using aluminum oxide and ethanol. Utapata tu mtu ameandika, amechora ile diagram mpaka iko na this funnel. Alafu aweke aluminum oxide kwa this funnel na aweke ethanol pale kwa nini. That now will be very cantankerous for you. So that's the setup that is used to prepare ethene using aluminum oxide. Of course, you heat, you collect the gas over water. Already you know this one must be slightly soluble in water, and that is why we are collecting it over water. Could I proceed?
Carbon dioxide produced here?
No, not really. We can, but still it can still be it can still be produced because the temperatures are very high. But remember now, you first eat the ethanol. Ethanol, even within the temperature, even of around 70, it change. So the first component you are generating ethanol vapor. So what ukiweka glass will soaked in ethanol, then now you heat it, within the temperature of 60, ethanol itatoka. So mali temperature itakuja kuwa 300 ni mali kuna hiyo aluminum oxide. So in that kind of a scenario, but remember for the other one, the entire temperature of 180 occurs when the ethanol, the entire ethanol liquid is still there. So that can lead to decomposition of that. But this one can still be able to be produced again. But for the other one, it is a must. For this one, it may or it may not. But due to the conditions of that setup, it is assumed the carbon dioxide is not produced in this setup. But even if it was to be produced, it's only carbon dioxide. There will be no sulfur dioxide like in the other side. Sawa?
Yes.
Yes.
Okay, perfect. Precautions. When you are setting up these experiments, ethanol is highly flammable. So you use the water bath. Concentrated, or rather, is a precaution. So you need to make sure that when you are setting up, you don't measure that you don't bring the ethanol in contact with the naked flame. Concentrated sulfuric acid is very corrosive on skin contact. So you use that. You can use protective clothing. You can use gloves. Common school thermometer has a maximum calibration of 180, and that cannot be used. So, of course, you can be very sure there's no teacher who will prefer that one in the lab because of the danger that are involved. And of course, the thermometer that we use, we don't use the normal school thermometers. These thermometers are usually they go between -10 and 110. And therefore, this one we are talking about the temperature of 180, 160. So it cannot be used. So we use a different type of thermometer. Physical properties of alkenes, these ones I don't even teach. Usually they are just direct. Can you just take a screenshot? They are colorless, they are liquid and solid that are not poisonous. They are slightly soluble in water. And that's why they are collected over water. Can I proceed?
Yes, mwalimu.
Yes.
Sasa shida iko hapa sasa. Hapa ndio mtihani karibu yote. This one is the darling of the examiner. This one is where now you find so many questions. The melting point and boiling point increase as the carbon chain increase because of the increase in the number of van der Waals forces with the increase in molecular mass. So that statement it applies from alkanes all the way to alkanoic acid. So remember, this one is a common thing. It will apply for all organic compounds. For all organic compounds, the melting point and boiling point will increase with increase in the carbon chain. That is now from ethene to propene to butene to pentene. As the carbon chain increases, or rather as the size of the molecule increases, there'll be increase in the melting point and boiling point due to increase in the number of, let me give you the one that, kwani imeenda wapi tena? Not number. Okay. Increasing, no, not number. Increase in strength. The most important thing is strength of, due to its increased strength of van der Waals forces with the increase in molecular mass. And that applies to all, this thing applies to all molecular substances. The larger the molecule, the stronger the van der Waals forces, and therefore the higher the melting point and boiling point. Even to, right from alkanes, ukiambiwa compare the melting point of ethane and pentane, utasema pentane has a higher melting point and boiling point than ethane because pentane has a higher molecular mass, therefore a stronger van der Waals forces. Even to, so let it be known that this point will apply from alkanes, alkenes, alkynes, alkanols, and even alkanoic acid. So just know it is the same. The larger the molecule, the stronger the van der Waals forces, and the more the what? The higher the melting point and boiling point. The only mistake many students here say, wanasemanga, the melting point and boiling point increase down the group. There's no group here. These are organic compounds. We only talk about their change in terms of the carbon chain, like from methane as one carbon atom, ethane as two. We have propane as three, just like that. So the melting point and boiling point increase as the carbon chain increases due to increase in the strength of the van der Waals forces. I think that point is clear, and it should remain like that right from alkanes all the way you're going to talk about alkanoic acid. It's just going to be the same. Perfect?
Yes.
Yes.
Perfect, mwalimu.
Yeah.
Perfect.
One is wrong. We continue with this one. So the solubility in water decreases as the carbon chain increases, as the molecular mass increases, but very soluble in organic solvent. Of course, these ones are insoluble in water, but very soluble in organic solvent. But tunasemanga they are slightly soluble. So the smaller ones are more soluble than the higher one, because the one with longer chain, they are less molecular. You know, the larger the molecule, the more it becomes more molecular. And that's why it becomes more non-polar. So it is not going to be dissolving in water. So, but now these ones are soluble in organic solvents like tetrachloromethane and methylbenzene. Simply, you can just say these ones are slightly soluble, they're insoluble in water, but soluble in organic solvents. So slightly soluble in water, but very soluble in organic solvents. This one is just summarizing what you have done, right from the formula. Imepeana melting point, boiling point, zimeenda zikipungua. Some are gases, then as they continue, they become liquid. So the only important thing is just to know that as you move down, as the carbon chain increases, we talk about as the carbon chain increases. Because here we have, this one has 2 carbon atoms, these are 3, these are 4. So there's increase in carbon chain. As the carbon chain increases, then automatically that increases the what? That increases the boiling point or the melting point due to increase in strength of the van der Waals forces. That was just explaining what was explained. So I want us to have a look at this question. The diagram below, we are yet, but let us review that part of preparation. The diagram below was used to prepare a gas X in the laboratory, of course, and studied and answered the question that follows. So already the gas is given, which is the ethene. So this gas that is being ethene, what is substance S?
Ethanol.
Ethanol. Perfect.
Ethanol.
Now, what property of ethene allows it to be collected by the method shown?
It is less dense than air.
This one?
Slightly soluble.
It's slightly soluble in water.
Slightly soluble in water. Remember, all gases are slightly soluble in water, except what?
Ammonia.
Except now, Nasema, for all the gas that are collected over cold water, we say they are slightly soluble in water, except hydrogen, whereby we are going to say it is insoluble. Hydrogen is the only gas that is completely insoluble in water. All the others are slightly soluble, like the likes of ethene, hydrogen, oxygen. No, the likes of oxygen, carbon 2, we have nitrogen gas, we have nitrogen 1, we have nitrogen 2. So all those ones are slightly soluble, but of course, for hydrogen, we say it is completely insoluble. But we have nitrogen 1 oxide and hydrogen sulfide, which are collected over warm water. And I think you have checked my YouTube, whereby I've analyzed the preparation of gases. So please go and look at the octopus. I've just used one video of about 13 minutes to summarize the preparation of all the 18 gases in chemistry. So please, before you get back, just go and check on that preparation of gases. I've done it in the YouTube. It will go to summarize.
Yeah.
Easy for you to be able to revise on gases. Sawa?
Yes.
Good. Alkanes are unsaturated. What is the meaning of unsaturated hydrocarbon?
It has a double carbon-carbon bond.
These are hydrocarbon with either double or triple carbon-carbon bond. So that's the meaning of unsaturated. It can have double or triple. Okay. Hii mnaweza jaribu, wacha nikupee tu, mnaweza screenshot, then you can try it. I'm just going to give you that thing. Maybe uone ukiona kama kuna moja inakaa kitu ngumu, then useme. I'm just showing you the question that can come from this end. My screenshot your page, eh?
Yes.
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 Okay now? What about that one? Now, short down the questions.
Yes.
Yes.
The other one. By the way, that homologous series is what? Either of it to make click. I want to answer that one before. What is that homologous series is which one? What name is given to those members of that homologous? What is the series of organic compounds like the ones in that table? What do you call them? What name do you give them?
Alkene.
Alkene.
Okay. Give the name of the fourth member of the homologous series. Give the name of the fourth member of the homologous series.
But1ene.
The fourth member is what?
Pentene.
Yeah, you see, many people are saying, and that is a very common mistake. I want you to look at this. Remember, for alkenes, the first member is ethene, not methane. So the first member is ethene. The second is propene. The third is butene. The fifth is pentane. So in that kind of a scenario, the fifth member, the fourth member cannot be but. It can only be pent. So when you're told to name the seventh member, it will be what? Yeah. Yeah. But then you see now we are only telling you because there are so many formulas of this. So you can, that's why the examiner is telling you to write the formula. So the formula of the seventh member will have what? Will be C what? Will be C?
7.
C8.
H16.
Listen. It is going to be C8.
H16.
H16. Kuna mtu hapo anaona bado anachanganyikiwa. Tukisema the first member iko na 2 carbon atom, haina moja. So ukiambiwa the fourth member iko na how many carbon atoms?
5.
5. Ukiambiwa the sixth member iko na how many carbon atoms?
7.
Unaelewana sasa eh?
Yes.
That's a common mistake with students. Whatever you tell you, name the fourth member of alkenes, alkyne, they always assume the first one is methane, which is not there. So make sure that you are able to get. So, so we go to the second session. I had broken it into. You have a question?
Yes.
Uliza.
So if ethene is a gas, and we can see that it has a boiling point, how can we explain this?
Well, remember, okay, perfect. You're wondering why something is a gas and it has a melting point, a boiling point, because you can tell, don't assume that that issue of saying ethene is a gas is only based to the standard conditions of temperature and pressure. That is simply based on room temperature. It is a gas at room temperature. If we cool, that's why we talk about now. Have you ever heard of the boiling point of in Form 1, symbolism of rational distillation, whereby you said the boiling point of nitrogen is this, the boiling point of nitrogen 196, the boiling point of oxygen is a negative 183, the boiling point of argon is negative 186. Every substance has a melting point, a boiling point, because you can cool it to solid state, you can freeze it, and you can also condense it to liquid. That issue of saying ethene is a gas is only based on the room temperature. Sawa?
Yes.
Yes, that's why ukiona hiyo boiling point imepeana negative something. So you can, even oxygen has a, we can even convert, just the way we know water is a liquid, but that we say water is a liquid at room temperature. But do you have a freezing point of water?
Yes.
Do you have it? Not freezing. Do you have the melting point of water? Water still melts because you can still cool water to solid state. Then you can allow it to melt. And that is something, at least water is something that you can do because you just need a freezer. You put some water in the freezer, it's going to change to a solid. When you remove it from the freezer, where the temperatures are out a little bit hotter, it will start melting. And I think now that I am clear about that. Sawa?
Yes.
Now we are going to describe the chemical properties. That is the epicenter, and the center of chemistry is of organic one is based on the chemical properties of alkane. You're going to find a lot about this. So let's start with the first one: burning. Alkenes burn the yellow sooty flame in excess air to form carbon dioxide and water. So alkene plus there, you're going to get carbon dioxide and water. That is when there is excess air. What if we burn it in limited supply of air? We put a pattern in. You're going to get, huh? You're going to get carbon. Yeah, so first of all, kumbuke, alkene will burn in the yellow sooty flame. Ukiona yellow sooty flame, ujue hiyo kitu ni unsaturated. But something like ethene, like that's why you can be told to differentiate between ethane and ethene. So hiyo ndio kitu utakuja kuulizwa. Differentiate between ethane and ethene. So if you have used the guru, you have seen the first question there. So you can burn them. This one will burn with the blue flame, while the other one will burn with the yellow sooty flame. That's a way of differentiating them. I'm telling you because these are things, utafunza to then all of a sudden unapata examiner na kuuliza, how can you differentiate between ethene and ethane? Then unashangaa nini you get. So you need to understand that to differentiate them, you can burn. Ethane will burn with the blue flame. Ethene, because it's unsaturated, will burn with the yellow sooty flame. Sawa?
Yes.
Yes. So anyway, all organic compounds will burn to produce carbon dioxide and water. Any carbon compound that burns will burn in excess air to form carbon dioxide and water. Anything that burns in limited will give you carbon dioxide and water. That is a general thing. Maybe somebody had not taken that one. Can I proceed?
Yeah.
Yeah.
Okay. They also burn the yellow sooty flame in limited air to form carbon dioxide and water. Again, there is nothing to be explained there. So it's just as straightforward as shown.
Yes.
Na tuende kwa addition reactions. Sasa hapa ndio chemistry inakuanga na shida. So now, I want you to figure yourself. Let me stop sharing first of all. I want you to figure yourself holding your friend. Kama umekuwa umeshikana na rafiki yako ama you let me just give me 1 minute to be able to do something here to get some charger for my laptop.
Yeah.
You guys, sister.
Okay. I think we are all sorted. So just a few things. So I was saying, like, assume you are holding somebody. Assume mko wawili na mmejaribu kushikana. So mkiwa mmeshikana hivi, let me use my video. So now you are ordering somebody with two hands. So alkenes undergo what you call addition. Unaweza kuwa umeshikana wawili na umeshikana umeshikana watu wawili na umeshikana na mkono mmoja. So that kind of a scenario. Sorry. Trying to bring some lightning my hands. So in that kind of a scenario, if you are ordering your friend with two hands, umeshikana wawili hivi, you can still release. Unaweza toa mkono mmoja na bado ubaki umeshika rafiki yako. And then if there's somebody else who wanted to be held, he can still hold you. So that kind of a scenario is very much important. If Obiro is there, you can make me a co-host, because I may need to have some small superior powers to do something. Now, in that kind of a scenario, we are saying umeshikana rafiki yako na umeshikana na mikono miwili. Now, are you able to remain holding your friend and still make your other hand free and hold somebody else? Unaweza shika watu wawili, isn't it?
Yes.
Yeah.
Yeah.
Yes.
But when you are holding two people, assume now you have your two brothers, unaweza shika moja hapa na mwingine hapa, mkiwa mnatembea hivi.
Yes.
It is
Yes.
possible.
Yes.
Yeah.
But now you see now,
Uh-huh.
if now umeshika watu wawili, mmoja na hii mkono na mmoja na hii mkono mwingine, is there any option of now adding holding somebody else? Kuna chance ya kushika mtu mwingine na bado ubaki umeshika watu ulikuwa umeshika kweli?
Yes.
Hapana. Hapana.
Iko.
Be normal.
It depends with the gender, teacher.
With what? No, we are saying with the same energy of holding two people. Kishika watu wawili, you are already saturated. Be normal. Well, don't behave like a synthetic allotrope. Now, when you are holding two people hivi, nimeshika, mimi naweza shika, mtu mmoja anaweza shika tu watu wawili vizuri, ashikana mikono. Pia tumeshikanisha watu mikono miwili. Then, if now you are two, na umeshika mtu mmoja na mikono miwili hivi, you can still remain holding that one person. Na bado hii mkono mwingine ikuwe free, you can hold somebody. The other person will also do the same. So in a short, mnaweza kuwa watu wanne mmeshikana in a straight line. Is that possible?
Yes.
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 Okay.
Yes.
I want to explain concept here. I wish mlikuwa mahali mko wengi. I could have demonstrated that one in a very magnetic manner. It's very easy even to demonstrate it in a normal. I've done it several times. You can easily show it. Very easy. It's very easy to show that kind of a thing. It's very easy. So I'm trying to look at my Zoom. Okay. So I think Rocco is being taken. So let people take their Rocco very fast. Mr. Obiro is taking Rocco. I think now I can give you 2 minutes to do the Rocco. 1 second. Rocco. And there's a class called Q, and it has nobody. It has only 7 students. Just make a mistake possible. If you're in my class and you come back to school without those notes, you'll be done. Congratulations, K, they are doing very well with attendance of 21. D, Pia, doing very well. A. Then the worst class is Q. Watu wa Q mko wapi?
Tuko hapa?
Only 7.
Yes.
But it's only 7 people wenye wanaonekana kwa wamefanya roko. Why?
Wanatuonea.
Eh?
Hapa.
Sasa unaonewa na nyinyi ndio mnafanya roko.
It's very queer.
But anyway, bora tu umefanya, wenye wanaongea na Joe umefanya roko. Wacha tu wale majamaa waonekane, tutawapata tu. You know, you can know in chemistry, the alliance is the headquarters. So you cannot joke around with chemistry. How now? You know, like. So I think Paul ended for Elisha, so now we can continue. Okay, just before I continue, kuna there's the Sami mwenye aliuliza, what about naming propene where the double bond is still between the first and the 2? Propene, you can only have prop 1 in. You cannot have prop 2 in. So propene and ethene is simply named ethene and propene. We don't have eth 1 and eth 2. We are the same way we don't have prop 1 and prop 2. Nelson, sijui kama kuna mwingine alikuwa na hiyo shida. I can still explain it better way.
Well, my question was,
Yeah.
in the notes, it's just propene. It's not prop 1 in. So it just my question was,
just one, you know, look here. Sahi ukianza kusema tuseme umename hii kitu itakuwa aje 1 2. So the double bond itakuwa between the first and the second. Utaita prop 1 in. So tuseme now you now change the double bond. Alafu sasa uilete wapi? Uilete sasa hapa. Si bado itakuwa 1 2, it will still go to be prop 1 in. So we cannot have prop 2 in. Therefore we don't identify, we don't specify. We just call it propene. It has no other name. You only start specifying whether it's 1 or 2 when there is a possibility of having different structural formulae. For ethene, for propene, it can only have 1 structural formula, and it is simply called propane. You don't have to give it another name. Sawa, Nelson?
yes.
Yeah, that's the rules. That's the UPAC rules. Addition reaction is one which a molecule reacts with another to form a single product. Addition reactions of alkenes are named from the reagent used to call the addition, but normally we just call it addition. So now, normally now, in addition, you remember with the alkanes, like when they are reacting with chlorine, we are often forming 2 products. Like if you have ethane plus chlorine, you're going to get chloroethane plus hydrogen chloride. But for this one, we only form 1 single product. We call it addition because it is added. So the atoms of the product being added, zinaongezangwa. So the product will have the reagent plus the atoms of the reactant. So what happens during polymerization is this, not during polymerization, during addition. Hii double bond huwa inavunjika. Hii double bond huwa it is broken down. I feel very bad that the lights are so bad. The double bond breaks. So vile ilikuwa hapa, hii ni double bond venye naonyesha mkono. So hapo nimeshikana na mtu mwingine. So what happened? Mimi nabaki nimeshika huyu, juu tulikuwa tumeshikana. Picture it. Figure it out like this double bond ni kama umeshikana na rafiki yako. Are you figuring that idea?
Yeah.
Are you using Nakuwa kama brother yako, shika brother yako na mikono yote miwili. Hiyo ndio double bond. Alafu toa mkono mmoja, muachilie na mkono mmoja ubaki umeshika na moja. That's exactly what has happened here. Hii double bond ni wewe umeshika brother yako ama sister yako. Umetoa mkono mmoja, ukabaki bado umemshika na moja, na hii mkono ingine ikabaki ikaenda hii side ingine. So imekuwa free. Ndio hii sasa free hand. Free hand hapa. So now those free hands now they can odd. Wewe unaweza shika mtu mwingine kama you have another brother, na pia sister yako anaweza shika mtu mwingine. So now you add, those are like added atoms. So remember, now when we're having these, initially the concept of addition appears like that. These are double bond. The double bond now break to form single bond. So hivi now itakuwa free. So any additional atoms itakuja kuongezwa hapa. Because remember this one, kama hii ilikuwa, tuseme hii ilikuwa methane, si bado iko na hydrogen yake? Unaona? Unaiona?
Yes.
Yeah. So now if this one was reacting with chlorine, si chlorine iko na 2 atoms. Tuseme ilikuwa na react na chlorine gas. See, one chlorine atom itakuja jiattach hapo. Sorry. Andika nini sasa? Nitumie a different color. So one chlorine atom itakuja ijiattach hapo na ingine ikuje ijiattach hapo. So these ones are added, but these ones they just remain. So whatever happens is during addition, the double bond will break, ikuwe single bond. Alafu ikikuwa single bond, there will be now free ends. Itakuwa na free ends whereby we can add the other atoms. That other atoms will be added by those free ends where the double bond was removed. So first of all, the double bond changes into a single bond. And then the atoms are added to that point. Umeshika?
Yes.
Yes.
Okay. Let me do it practically. Let me do it practically. Acha tuende kwa neneo. Tuangalie. Okay. 20 types of addition. Kuna addition, hydrogenation. Reaction with hydrogen, we call it addition, hydrogenation. So this one, sometimes we normally call it hydrogenation. So this is exactly what happened. So addition, halogenation. But the keyword, the only one we identify hydrogenation is this one. Hizi zingine zote tunaziita addition. Reaction with the halogens, reaction with the hydrogen halides is simply called addition. So just write that the types of addition reaction. Reaction with hydrogen is called hydrogenation. But reaction with halogens and hydrogen halides is simply called addition. Usiaisema kitu inaitangwa halogenation ama hydrohalogenation. If you are taught the type of reaction, it is only with hydrogen that you're going to call hydrogenation. For the other two, reaction with halogens, a reaction with hydrogen halide like hydrogen chloride and hydrogen bromide will simply be called addition. Tunaelewana, students?
Yes.
Yeah.
Yes.
Let me repeat, because you are going to get confused and you find some confused books. For purposes of examinations, addition with involving hydrogen, unaita hydrogenation. But addition that has halogens and hydrogen halide is simply called addition. And that is the only thing. So let's see. So hapa tuko na hydrogenation, the first one. Tunataka kureact na hydrogen. So what will happen? We have ethene here. Ikiwa na double bond yake. So what happens now? Hii hydrogen iko na moja, iko na moja. So what happens? This double bond break. Iki break, vile nimekuambia kama kesi ya mkono, this will change now from a double bond to a single bond. And then we'll have a free end here and a free end here. So hapa itakuja sasa ni kama mkono tu. Venye nikuambia mkono ni mbili imeshikana hivi. So hiyo free hand moja itaenda ya hii. Ni kama watu wawili wameshikana. Picture one carbon is one a boy and the other carbon is a girl. Wameshikana mikono hivi. Then waachane. Wacho umemshika na mkono moja na hii ingine ikuwe free. So hiyo free hand now inaweza ongeza mtu mwingine. Huyu akushike na huyu ashike. So in that kind of a thing, we are able to add that. And that's the simplest thing to understand. Wherever you're having a double bond like that, just break the double bond to a single bond. Let the free end, we had the remaining atom. So kama hapa hii ingekuwa chlorine, hapa instead of hydrogen tungeandika nini?
Chlorine.
Chlorine. Kama ni bromine tungeandika nini? Bromine. Are we together?
Yes. Yes.
Does it make the work easy?
Yes.
Yes. So now something to understand. Good. Nimekuja. Power has come. Now, something to understand is that this reaction or this process is called hydrogenation. It requires a temperature of 150 to 250. It requires nickel or palladium catalyst and pressure of 200 to 250 atmosphere pressure. The reagent is hydrogen. And remember, when you write high pressure, it will not score. Remember, the examiner will ask you, you're converting ethene to ethane or propene to propane. What is the reagent? The reagent is hydrogen. What are the conditions? We require palladium or nickel catalyst. We require a pressure of 200 to 250, and the reagent is hydrogen. So make sure that you are able to capture that. It's very much important.
Sure.
And yes.
In the exam scenario, do we give a range of temperatures? Like, for example, let's say 150 to 250, or do we give a specific one?
For example purposes, you just give you give a specific temperature within that range. Unaweza sema temperature of 180. Unasema temperature of 200. But just remember, the most important things are the hata vitabu hazijaongea mambo ya pressure, but of course we require nickel or palladium, or we require that temperature of 200. So make sure that at least you know two, like the pressure and those the temperature and the what? The temperature and the catalyst. So that is one thing. And of course, also remember that we also, this is the way, this is now how we convert oil to fat. Ulisikia ukiambiwa hydrogen in form 1 is used in manufacture of margarine. In your process. This is now the process that is used in manufacture of margarine, because somebody will give you this question, this kind of a reaction in the exam akuulize, give the industrial application of the process above. Then utasema it is used in manufacture of margarine. Somebody can even be able to tell you to explain how oil is converted to fat. Then you're going to say bubble hydrogen gas through oil in presence of nickel or palladium catalyst and temperature maintained at 200 degrees Celsius. Nakwambia, unaweza ambiwa describe how you can convert oil to fat. Then utasema, you remember, this is the process of hydrogenation. So you bubble hydrogen gas through the oil in presence of nickel or palladium catalyst and temperature maintained at 200 degrees Celsius. Because
Yes.
That's how question can be tested. In fact, it answers like the question can start like this. A student from Alliance High School wanted to obtain oil from groundnut. He crushed the groundnut. Then the examiner answered na kitu rahisi sana. Name the two apparatus that were used.
Mortar and pestle.
Pestle and mortar.
Name the solvent.
A mortar
Name
and
the
pestle.
solvent. The solvent used is what?
Propanol.
Propanol.
Good. Then you are told, describe how you can convert the oil produced into fat, stating the condition and the reagent. Then you're going to tell us now, bubble the hydrogen gas through oil in presence of nickel or palladium catalyst. And of course, then with the temperature maintained to 200, then the oil will be converted to fat. Lazima uelewe chemistry kuwa imeingia kwa blood. Vizuri sana. Angalia hii swali sasa. Angalia this one. Sasa hapa angalia mahali. This is now propane. The double bond, unaona mahali double bond iko? Are you seeing it?
Yeah.
Yes.
So hapo ndio bado ita break. Iki break itakuwa na free end. So hiyo iki break ni kama hii ni watu watatu na wenye wako na double bond ni hawa wawili. So the atom that is about to be added lazima ziongezwe kwa hizi carbon mbili. Haziwezi ongezwa kwa hii ya kwanza. Are you understanding?
Yes.
In addition, can only kind of that point. So we are going now to have the hydrogen. So this one breaks to a single bond. Then hydrogen moja hapa, hydrogen moja hapa. Si lazima unaweza iweka hata juu. It doesn't matter. Hata hii unaweza weka hii hapa na hii ingine. Ni vile tu tunataka kuiweka tu vile inakaa hapo na ile ingine hapo pengine. So it is very simple. Just convert the double bond into a single bond. Then add the atoms that are being added there. Then you just add them there. Then you have your compound. If this is propene, it changes to propane. Does it make your work easy?
Yes.
Yeah.
Yes.
Industrial application of hydrogenation. When hydrogen gas is bubbled through liquid vegetable oil at about 180 degrees Celsius, in presence of nickel, solid fat is formed. Hydrogen is that used to adding oils to solid fat, especially in manufacture of margarine. Umepata hiyo point vizuri sasa?
Yes.
Yeah.
Okay. Have you taken a screenshot?
Yeah.
Addition, halogenation. Now we have additions of the only thing here with halogen, we're just going to be adding halogen, fluorine, chlorine, bromine, iodine to form the alkane. So that's the point. Just the same. It's just the same. Here we have the kuna mtu hapo ako na hajamute. So somebody, whoever is in charge of muting, can you mute? So it's just the same. So the only thing that we are changing here is here, instead of hydrogen is now bromine. So the same thing will happen. So the double one will change to a single bond. Bromine atom will be added to one side. And now the name becomes 1,2-dibromoethane. There's a problem here. Let me see. ED, this D should be a small d, not a capital D. Let it be known and try to understand because of I'm using this is a small d. Can you let it be known that that's a small d, not a capital D? So we cannot put a capital between name. When you are naming something like that, we assume the first E number and your capital. So that's a mistake of type. So does it make again your work very easy? Because you see now, it's just the same way. Once you understand how to do addition for hydrogen, you can do for the others. The only difference is just because it's bromine, you're going to put bromine. If this one was fluorine, you're going to put fluorine. Are you understanding?
Yes.
Are you understanding?
Yes.
Perfect. Then with fluorine, the same. This propane, together profane, together fluorine gas. So the double bond will change to a simple bond. Then one fluorine upper, and then becomes 1,2-dibromo. This one is still a small d. So 1,2-difluoropropane. And remember the name is now changing to propane, not propene, because Now we have changed from a double bond to a single bond. And I think this one is very clear. You can now answer anything on addition, isn't it? Is that correct?
Yes.
Then with this one, yes, reaction with bromine water. Bromine water is not HBr, it is HOBr. That is bromine water. So what will happen? HOBr, ukibreak itakuwa na OH na bromine. So when now you are now adding it, hii inakuja, ina change, neutral ndio hii. So iko na OH na iko na Br. So this is thin. Ikibreak changes to a double bond, to a single bond. So inakuwa OH na hii ingine inakuwa Br. So this one becomes 2-bromoethanol. 2-bromoethanol. This one should be a small b, not a capital B. So it changes from yellow to color. As we say, that is test for unsaturation. So if you are taught how to differentiate ethene and ethane, you say you can bubble the gas through bromine water. Ethene, the bromine water changes from yellow to colorless. For ethane, the bromine water remains yellow. Unaelewana, eh?
Yes.
That's a test for unsaturation. That is a way of differentiating. Now nimewapea njia mbili za differentiate ethene and ethane. First of all, you can burn. Ethene will burn with a yellow sooty flame. Ethane will burn with a blue flame. You can also use bromine water. Ethane will not decolorize yellow bromine water. Ethene will decolorize yellow bromine water. Umeelewa?
Yes.
Yes.
Yeah?
Yes.
Addition hydrohalogenation, hiyo ni ile reaction with hydrogen halide, just the same. Tofauti ni vile tu hapa tunaweka hydrogen na bromine. So what will happen now is the same will change from a double bond to a single bond. Side moja tumeweka bromine, hiyo ingine tumeweka hydrogen. Hivyo tu. And things become very easy, just like that. There's nothing that you need to explain here. So note that there's a difference between bromine gas, vapor, which is brown, and bromine water, which is yellow. Don't confuse the two. Bromine gas is brown, but bromine water is yellow. The reaction between alkenes and HOBr, that is bromine water, turns, it not should be turns, should be changes. We talk about changes. Changes from, let's see. Okay. Changes, that is the word. We are no longer now using the word turns, so we use the word changes. Changes from yellow to colorless. In practical paper 3, we use bromine water, which is yellow. So not that brown, red, brown, the color bromine is penalized. So we don't accept that. So remember, these are some of the issues that you're going to be dealing with. Ukiona bromine water change it from purple, from yellow to colorless, una confirm kwa inference, double bond, triple bond present. Revision exercise, study the flowchart below and answer the question that follow. Because that one is now, that's not under your near, we'll be able to look at it later. But of course, I can just give you this kind of thing. You see, this is ethene, process 1 being changing to C2H6. What are we adding here? What are we adding there?
Hydrogen.
So what do you call that process?
Hydrogenation.
Hydrogen. What are the conditions?
Palladium.
Nickel catalyst.
Nickel catalyst.
Nickel or palladium catalyst. Step 2. What is the reaction that we're adding there? What is the reagent? What is the name of that reaction in step 2?
Addition.
Halogen.
You just go lead addition in pressure. You don't have to pressure pressure. Simply addition. And what's the reagent there?
Chlorine.
Chlorine.
The reagent is not chlorine. The reagent is HCl. Get the difference. Kama tungekuwa tunaleta chlorine tungepata C2H Cl2. Kama tumeongeza chlorine, the entire 2 atoms of chlorine are added. Si mnajua addition venye ilikuwa nafanya? But look at this one. The product has how many hydrogens? Oh, by the way, this one should have been 2. CH2. CH2 should have been like this. So what have we added here? You see the reactant iko na hydrogen ine, but the product iko na 5, meaning kuna one of the hydrogen ilikuwa pale, and the product has only 1 chlorine, meaning that whatever has been added to this compound, the form E, is hydrogen and chlorine. So the reagent is HCl. So don't be jumping into conclusion just because you have seen chlorine in a product, then you say the reagent is chlorine. Tunaelewana?
Yes.
And then we have come to the end of our lesson today. Thank you very dangerous for your attention. I think you have again some things. I think when you get back to school, you will be able to be more magnetic. And of course, nilisema, yes? I have put the entire organic in the YouTube. Please check on it. And of course, be able to that was the question. These are the questions.
Should you write the notes?
Yeah?
Should you write the notes?
Yes, you're about to write the notes. Why not? Because I have given you, I want to believe you are screenshotting. And I've said everything, if for those who missed it still the YouTube, will look at those notes because they have seen some people who are joking around. If I've been here sitting here teaching you for that time and we cannot get 200 people, that is not a very good. But for those who have attended, thank you so much. Thank you for attention. See you when the schools open. That is possibly you're coming back on is it on Monday or on Tuesday?
Thursday.
What about the
Huh? What about the
octopus?
Thursday.
octopus? You want the octopus? Of course, we have to finish this before you do the octopus. The octopus, I'll do it. Of course, it's in fact, it's the YouTube. The octopus.
You're giving us the assignment on octopus.
Huh?
You're giving us assignment on octopus.
Yes.
Which one? The whole of them. So we should leave out organic chem.
Yeah.
We should leave out organic chem or rewrite it.
No, you can just try to do what is manageable because you don't have a lot of time. I think now I'll allow you to be able to. There's some assignment you are given on octopus.
Yes. Yes, you gave us.
Oh, you need to work on it. You know, you work on what you are given. Then when we meet, we'll be able to see. But I expect the things that I've taught when we get back to be able to see something from you people. I think you have benefited and I think you have learned something and I think you can be able to revise. Please take your books and revise. If you have book 3 top notch, you can be able to answer most of the questions from there. Of course, because there are so many questions from there, you can also use the Octopus Guru. It's going to be very easy. I've said I've analyzed the entire organic from organic 1 to organic 2 in the YouTube. So please, if you have time, just go there and check on it. Otherwise, all the best. Whoever is the host can end the meeting.
Thank you, Malcolm.
Thank you, bye.
Thank you, Mwalimu.
Okay, asante.
Thank you, Mwalimu. Dangerous.
Yes, I gave some assignment which had question above their level, so those one don't answer.